the recording. All right. So again, welcome to the first iteration, this like first online version of this semester. Uh, can I open the submission? Oh yes. Can you send me an email just to make sure I'm on the same page and I have the recording of like what I say? All right. I just want to make sure that that's the case because for you in specifically because you are in a tight situation that I really want to make sure I help you. All right. Um. Okay. So lecture 4. Now we talk about something that you all will find pain throughout this semester. Something that some of you might have run into already. Something that pop up when you compile and run. After you run, it show up seg fault, segmentation fault. What is that, right? So today we'll talk about all these things. But before we begin, again, we'll have a makeup class for so basically we have to make two makeup classes, right? One is for the gas leak, the other one is for the the day that we have the Nakhon Pathom province has a gas leak. The other one is for the October 13th, right? Where it was a holiday and obviously I cannot like do a lecture on that day. So we'll do one on Monday. And as I told you, all these makeup class will not affect the main lecture. So we will not introduce any new content, but the goal of this particular makeup class is for you guys to ask me questions about C, assignment 2, the upcoming assignment 3, which I will release before. This semester, I will do it a little bit more fun where you see now that because we cover what I need for assignment 3 today, I will release assignment 3. You guys can take a look at that and think about how do I solve it. And you can come in on October 24th as well to ask me the questions. And we will do some review, some sample code based on your demand. All right, so this is student driven. Any topics that you want me to go over in more detail, especially if you can tell me ahead of time, I can prepare some of those material ahead of time. That would be much easier for us to like guide you, for me to guide you through those topics. We have online class again next week. I actually now forgot what is the reason. But yeah, it's open house day. And apparently we cannot use the building, so we do online class on October 27th. So there'll be two more online classes at least. The one on Monday, the one on Thursday. All right. And now let's do a quick recap. We talked about function in C last week, right? And as I said, similar to Java and Python, to be honest, we have function that have text in input. Right, input to the function. This is more similar to Java. If you program in Java before, the input needs to have a type. What does type mean? Whether it's an integer, a character, right, or a pointer, which we will learn what is a pointer today. The function is physically located in the memory, in the DRAM that you have on your computer. When you run a function, basically it invoke this add. For example, this is a simple add function, so it invoke add function, takes in A and B as an input, add them together, and return the results back. All right, and the C program, the runnable C program will have the main function. When you compile, whatever is in the main function, this is the first line of code that gets run. All right, so you can put whatever here, your code here, your code start here. All right, so you begin the code there. You can then call other functions. That's fine. We also have multiple data types like int, character, float. Today we'll learn about more things like array or struct. But these data types just represent the value, right? That's how computer represent any type of data. Integer, floating point, they all have specific bit pattern like ones and zero. And the value it represents, because it's ones and zero, you can always convert to a decimal number, right? So it just represents the value. So the value of 65, for example, is a letter A in character. You only have basic data type support, so you don't have true or false. Zero becomes false, non-zero becomes true. You can have control structure like if, and switch cases work normally. You can also have loops where you can use for loop, while loop, and do while loop, right? And you can use things like break to break yourself out of the loop, and you can use continue to skip to the current, like skip the current iteration of the loop, right? And you can have things like printf and scanf, where if the printf you print something on a monitor, and scanf will have the input reading from the keyboard, right, into the variable. And we will talk about what is this ampersand. Why do you need ampersand today? You can use the format string. So this part is the format string. So these are the format string. It tells is a special symbol that tells the compiler that, hey, this thing is special, so take the value from somewhere. Take the value from somewhere and use this particular format: decimal, hexadecimal, floating point number with how many digits that you want to print, right? And now we'll switch to the next set of topics, which is something you saw earlier, right? Things like pound include. What is that, right? So we talk about this thing called preprocessor. What is a preprocessor, right? This is there so that when you compile the code, it pre-processes some information about your C code. So these are things like your header file, .h file. We'll talk about all these things in more detail soon. Things like pound define, and things that are listed with the symbol pound followed by some syntax, like if n defined, if not defined, right? Then it tokenizes your file. Basically, this basically process your text, right? Because everything of your C file, if you think about it, it's just plain text, right? In main, those are literally alphabet int space main, right? So from the computer point of view, someone needs to come in and understand, hey, int mean is a data type, and main is a function name called main, and they take these inputs. So these are done during the tokenization and parsing. It parsed the text file, then tokenized your program's text to prepare that, hey, is this A plus B? The text A with the add sign followed by B, things like this, right? The text A plus B, right, become the symbol A for the variable that get add, right? So you take A and B, you add them together. This is basically tokenization. It allows you to kind of understand the program and the interaction of whatever the programmer tries to do, right? So these are the steps that the compiler will perform, right? Someone need to write this compiler program like GCC. It's actually a program that someone wrote to compile your code into some executable, right? This is a header file. So header file can be added to your C code by the command pound include. And you can do pound include with the bracket. This will be searching the .h file in certain environment variable, some part, right? Like standard IO. .h, or you can do this, pound include, and use the quotation sign, CLUDE, quotation sign stdio.h, right? This basically means it tells this to the program, right? Go and find this file called stdio.h at some predetermined location. That file will have the function definition for certain things you can run, like printf, scanf, because some engineer has to actually implement those two functions called printf and scanf. These are real function calls, right? The header file will allow the user to actually then use this some of the predefined function, or even things like function that you don't want to keep in the C file, right? You can define a function. I'll show you how this is done toward the demo part, which is the latter part of this class, how header file can be managed, right? So there are parts of the program, because the file .c can be really messed up depending on how complex your program is, right? So a simpler way for your friend to come in and try to figure out how does this program work is you include function calls and the definition of the function call, and like these are the input and text, these are the data type, put in the header file. The header file then allow the main file to basically ask and ensure that you implement all these functions. You can also implement a full-blown function call in the .h file as well, then GCC will know how to compile them, right? Some of these are pre-built functions like standard IO or standard library.h, right? These allow you to call functions like printf, scanf, or malloc, which is what we will learn today. And you can also use this for install library. For example, many of the some of the program I've been coding and using will use this Boost library in for C++, right? It's a library that you can download, and it is a standard for many of the implementation of basic data structure in C++, right? You can have things like a map, a queue, a linked list pre-implemented, and you can use them, right? So I can download this library, install it on my machine, and then call the function through the header file. That works too, right? So these are some of the things you can do for the header file, right? Then you have the pound define, right? Pound define, as the name suggests, is define what we call, sometimes we call this a macro. Basically this is called a macro. What is a macro? Well, the obvious one was just I want to define some name to a constant. For example, I can do pound define test 10. This means that whenever I see the text TEST, I replace that text with 10. I literally will replace any occurrence of test to the number 10, like to the alphabet 10. So this, think of it as you replace the text with the other text. You replace test with 10, search and replace. So for example, this is useful in a context like, let's say I want to debug, like I want to enable a way to easily print a lot of things if I want to debug my code, right? So what I would do is I do pound define debug one. This means that if in the future I do this, if debug, right? And then I have like printf, I print something to make sure I can like debug my code, right? If I say pound define debug one, this thing get printed. But if I want to disable debugging, I just say pound define debug 0. This if else will never happen, right? There's more explanation here, right? And you can use a fancy version of pound define, right? Because it's a macro, it does take arguments. We will not test you on this, but it's something that you can do. For example, if you don't want to write like a min function, right? You want to just define a macro, you can do define min AB, and then over here you define how you test for whether A is less than B or not. These allow you in the code, you can basically now type in min 34 or min input 1, input 2. Now C will know how to process that. For more information, you can find it here. You can do object linked macros. So these are really, really fancy. But doing this can be dangerous as well. So I do recommend to check the third link, which is like some pitfall that kind of tell you what else can go wrong. All right. Any question before we move on to how array is defined? Any questions? Great question. So one of you asked the question, why do we need define? Why can't we just create our own function, right? So let me motivate you by a few things. First of all, right, when we do the define, this is literally just do a search and replace the text, right? But if you have a function, you have to basically call the function. Basically, someone need to call the function then you compute, then you return, right? EURN. Okay, I cannot spell word. All right. So now here's what would happen. We have to do it. So over here, let's say the top part is a define, right? The bottom part is function call. When you have a function call, the OS will basically run your code, right? Your code gets run and see the function call. You need to first prep for the function call. We'll learn how this is done when we go through assembly, the third module of this class. Basically, you need to prepare the function call, followed by compute. For example, if I want to do min, right, minimum of A and B, the computation is to check if A is less than B, return A. If B is less than A, return B, right? And then you finish up the function call. This is basically return the value and make sure now the program jumps back to where the function call happened so you can keep running, right? Now, if I use define, if I use pound define, do we need to do the prep for a function call? Nope. Do we need to finish up? Do we need to figure out, okay, what line are we returning to? Or it's just in place function definition? No, right? So over here, if you use define, you just have the compute part. All right. So hopefully it is more clear, right? That, hey, it's actually, if it's like a simple function like minimum, or if a mod 0, mod 2 is 0, like if a is an even number, these things, well, how define is a good solution. Yeah, so it's more of that's one technique we call this inlining, which is instead of calling the function, you can literally type in inline. What C would do for the compiler would take that function call and copy and paste it inside the text. So you don't have to prep, you don't have to finish. That makes things faster, right? That makes things faster. Modern day GCC, the compiler, modern day compiler, sometimes they do this for you automatically, right? So with the modern day compiler, the current version of GCC, I can assure you, whether you use pound define or function call, it's likely to be about the same performance. Back in the day, it does matter. Back in the day, it does matter. Or when you have to like write a program for something simple. Like for example, this is a mouse, right? The mouse has to have some microcontroller on here to control. Hey, what will happen if I have to if I scroll things or I click, right? And then it had to read the input from the infrared, which is like right here, right? So that when you move the mouse around, it can tell that, hey, the surface changes and now we are moving the mouse around. So it updates whatever cursors on your screen, right? For these type of things, you might want to optimize your function call. You don't want to make it too long, right? Sometimes we call this a real-time application, which is like you want to make sure you never miss a deadline. So Poundify can help. Somehow you don't have a fancy compiler to work with as well. So to know this is something that you should at least be aware that they exist. As I said, great question. Thank you so much. So keep this coming in. These are awesome. Well, any questions are awesome. So if you are still confused about something, let me know. All right. In the meantime, so we'll move on to array, right? So that we have the rest of the time for the remainder of this class. So what is an array? If you think about it, array is just a collection of data that has the same type, right? The keyword is this. It has the same type. If you are going to the functional and parallel programming class, this is important for the definition of an array. It has a collection of data that has the same type, right? It's contiguous in memory. So this is a little bit more important when you think about the system side of things. It's contiguous in the memory, right? So let me kind of visualize what is an array, right? So when I say contiguous, so let's say this is your memory, right? when I declare an array, let's say array of 5 items, right? It means that the first item will be here, which is next to the next item, which again will be next to the next item, ARR2, ARR3, and then ARR of 4, right? That's what I mean by contiguous. Literally, they're right next to each other for each of these items. Clear? Data that has the same type, if it's integer, everything has to be a number, right? So to declare an array, you can do the bracket sign like int I10 or int char20, right? This is how I can define a string. So let me ask you this. If I say char A20, and I want to represent a word cat, right? Because I love cat. How many alphabet is in my word cat here? 3, right? C-A-T. So for my array, how big do I have to make? Like, what's the size of the array that would fit in my 3-letter cat? It's at least, if you have at least room for 3, right? You should be fine. But then let's say I have a character and I have room for 20 so that in the future I can replace the word cat with elephant, right? For example, then 20 letter, 20 room will fit, right? I can fit the word elephant in there. So my question, how can I tell that, hey, I only have 3 letters for my string and that's it, no more? Even when you have the array of size 20. Anyone have got an idea on like what can we do here? What can we do here? Well, when I actually, oh, you're great. So you have to have the concept of the edge, right? The end of my string, right? So first of all, you need a concept that is the end. And in C language, right, the way you do this is you add in one more value at the end. You literally put in the value 0. So that when you have a printf function, the printf function, what it does is we go letter by letter. C, okay, print C. A, print A. T, print T. 0, okay, I stop printing. Right? I'll stop printing. In that way, I will make sure that this is a string cat, and that's it. That's the end of my string. Right? So what's the value for letter C? If I say A is, well, lowercase a, I think it's 97. So C is 99, right? Over here, so the number will be 99. This will be 97, and I forgot what T is. Too far. I don't want to do the maths. And I might even be wrong here. Actually, forgot was like lowercase a. But let's assume lowercase a is 97. So the number get put in there, right? The number, great comments as well. I'll go to that. So the number I put in there is basically 99, 97, and whatever is the number for T, which I forgot, and the number 0, right? So let me ask you this. What is the minimum size of my array so that I can store the word cat safely? 4. You got it. You need at least 4 because you need that letter at the end that is value 0 at the end of the string. And you have the comments, or when do you have comments? You're awesome. You keep asking this. It's awesome. Why does it seem risky in production? It is actually can be risky if you don't know what you're doing. All right. If you don't know what you're doing in C, you can destroy a lot of things. You can destroy a lot of things, and this happen in many cases. To be honest, anyone heard about this thing called buffer overflow? All right. So for those of you who said yes, can you quickly explain on chat? And if you don't want to tell your friend wrong thing, or if you are not sure, you can send me a private chat. I'll correct that. All right, I'll correct that.
So I pay some the CTF, which is computer security for high school student. So I think buffer overflow is like basically when you have a certain type of data that you want to put in, and that data that when you put in, it exceeds like the amount of data you can. I think it's like some kind of capacity that you can store, and it costs, I think, like it caused memory to overflow, which means it
Yeah.
overflow on the
Yeah.
system.
Okay. Keep going.
Yeah. So in computer security, I think when you, I think there's a lot of security where you like, I think some people use buffer overflow to actually hack into some sort of system. Yeah, that's
Awesome.
what I know. But yeah.
Yeah. So in computer security world, buffer overflow is like a classic attack that you can do. Uh, when you write a program and you forgot about the size of your things, like for example, your string, right? Let's say I do char age 20. Someone can exploit that if you don't check what's the size of the thing that I just add in here, right? What are the bad things that can happen? So this is a blank slide. The reason why I show you might have seen that I took the slide down and then I have it back up so I can add this blank slide. So let's say I have the array of this size for my string, right? This is my array, and 1, 2, 3, 4, 5, 6, 7. So this is like char ARR7, right? I have 7 slots for this. Now, I can do things like getAs. GetAs is a function that takes in the variable, in this case ARR, right? And then it will wait for your input to the keyboard. From the keyboard, you can type in the inputs. For example, if I do getAs and I type in cat, right? Then the cat will be here, followed by \0, which is the value 0, right? And this is fine, right? This is fine. So let me use a different color for my text to make it clear. Hopefully more clear. CAT, right? And then the number 0 got put in here for my string cat, right? But what if I do this? What if I type in something like this? The dash is like space, right? Space. In space. What else? My attack and a followed by open bracket. I don't know. Do something crazy here. End bracket. What would happen if I type all this thing and then hit enter? The function would take my input and do this. Cat space, space. And then this is in your DRAM, right? And then this will be the part where it's like the int my attack will be in here, right? So one thing that the buffer overflow attack would try to do is, first of all, see if I can do this. So the first step, right, with the attack is first step is see if I can do this. The second step, which is this part, the number of junk character. Basically figure out the junk character, the number of junk character that I have to put in, right? Why do I need that? So what will happen? So let me ask you this. Because I told you the program is in the memory, which is, it means that your program that you're running right now is in the memory, right? So let's say I figure it out that this is your return function. Like the location where you return to, basically. This is like the location of the return point. Because when you have a function call, when you finish the function call, you go back to the code that call that function, right? But now you do what? Can someone tell me what just happened here? What just happened? I just put in the string, right, as an input for my keyboard to replace your code that you're running so that it return instead of returning to the function it's calling, it returns to my new attack that I just put in. And it will run that crazy thing you just put in, right? So this is the buffer overflow attack. So do you see at least some kind of flow of thought that things that can happen from the cybersecurity point of view, that this can be pretty dangerous when you program and you use some certain APIs and you forgot to check things like boundary, right? Buffer overflow attack allow you to basically overwrite the function call of the program. There's many things put in place right now to guard against this. Segmentation fault that you see is one of them. Awesome. So one of your question is like, but I thought ARR server would cap the amount of character that you should put in. So it depends on your implementation. But at the end of the day, right? At the end, think this way. Every single thing you do, there's some engineer writing that code for. For example, when you write the program in GCC, someone need to implement this getS function, right? Someone need to implement that function for you. So certain function calls assume that the programmer who used the function call to check that thing first, right? So sometimes you have this weird behavior where the programmer that used the function call forgot to check, right? And it allows you to read more than 7 characters. Another thing I can ask you, like, what if I put in and measure like my I have ARR of 7, right? But then here's my input, cat a. So I get S and this is my input. What happened? If I want to print this string afterward, I want to print out ARR, it will print CATAAA, and how can I tell that's the end? How can I tell that's the end, right? Because there's no null character, there's no room for me to put in the /0. So that case will keep printing. It'll keep printing whatever is in the memory until it reaches the point where that particular byte is 0. So again, you have a really legit concern, right? ARR7 should limit the cap, and modern day system has a way to check. So these days, it's really hard. It's much harder to do the buffer overflow attack because first of all, you need to bypass that check to make sure that you can write more than 7 things. So again, is it more clear now to you? Yes, it will check. and you should get something like segmentation fault. Segmentation fault basically means that you are trying to handle some location in memory, right? With your data, you're trying to store the data, write something or read something, but your program did not own that location because you didn't, it's not your own variable, it's someone else, because by accident you basically manage, like you mismanage your program and there's a bug, and you try to read, for example, the Mac OS like keychain by accident, right? Because you C give you that control. The OS, Mac OS will tell you, hey, that's illegal. I'm not letting you in. Segmentation fault. The word segmentation fault actually come from like a back then when you look at chip from Intel, like back before the day of like current modern day virtual memory, right? So we'll talk about virtual memory toward the end of this course. But back then, the way you create a space for each program, we build a segment in DRAM. We basically allocate a segment for that program. Segmentation fault means that you're supposed to work in this segment, but somehow you're reading from that segment right there. That's not your program. That's like the other program. So that's why it's called segmentation fault. That has a more like historical meaning. But fundamentally, what it is you try to access something that's not legal. It's illegal access. But again, this is a classic attack in the cybersecurity world because how many people realize that there's so many new language, new tools, new APIs, new function calls that you can use in Python, Java, C, and everything? Anyone realize there's so many choices right now? You can pick a bunch of things and you can try a bunch of languages, right? And a bunch of framework, a bunch of libraries, right, that other people implement. How many people believe that every single line of code get published in this world is bug free? I don't. I don't. Right? I don't. And it's actually pretty hard to keep tabs on every single function call that get built, right? So there's always new bugs that people can uncover, and this is one of the classic things you can try, right? All right, so now I talk again, get sidetracked. That's my thing, right? So let's, before we take a break, let's talk about data struct real quick, right? So let's say you want to combine multiple types of data. For example, I want an int and a floating point, right? You can use a struct in order to build, right? In order to build these particular type of data, right? So to use it, right? This basically create a struct that has integer and floating point, right? And then if you want to actually use it, you can use somename.a and somename.b to get each of the elements, right? And you can combine the concept of array of struct, right? That works. It basically acts like a typical array, right? Let's say you do struct somename. This is the type of struct, right? That have the integer and the floating point, right? And you can do ARR name 0.a. This would go to the first elements inside this array of the struct, right? And you can then define a new data type using the command typedef. So you can do type, because let's say I don't want to type always like things like struct some name. When I want to create a new struct some name, right? I don't want to write something like this because I'm lazy. I can do typedef, right? The typedef command is the type definition. Now I'm creating a new type. I call struct some name new name. So new name becomes a new data type. That data type will have one integer, one floating point. It will work exactly as a struct some name. right? I'll show you some example when we do the example coding because this might confuse you. There's a question on chat. Array of multiple elements of the same type. So struct are multiple elements of different type. Yes. Yes. It's like when you want to combine multiple types together, you can use a struct for that. And if you want to just go with like 1,000 integer, use an array. All right. And then you can combine an array of struct as well, so that you can have like a multiple copy of this pair of integer floating point, or like citizen ID and username and your name, last name. You can do that too, right? So for example, like struct person, right? And do int citizen ID char star name, because we are Thai, our name is long, so let's do 100 character. And then I don't know, floating point, date of birth, which I don't know why we use floating point here, to be honest. I'm sorry about that. All right, we can do this, and then you can say, hey, struct person Thai with the 100. Basically, this would allow you to store, right? Yes. So this allows you to store like a bunch of people, person, right, in an array. And this is kind of like when you query things from your database, right? If it's a structured database like SQL, right, then you will have this like every items that you query, you get like citizen ID, name, and date of birth, right? So there'll be an array of those. All right, so that's it for the first section of this class. So let's do a 10 minutes break. We'll resume at 11:15. All right, so oh, good point. I don't need that. I'm sorry. Thank you so much. Yes, you don't need star. Good point. Good point. Good catch. What do we write again? They don't have some amount of char in an array. We want to specify the amount of char in an array. So basically, you want some dynamic array, right? You can use pointer. We will learn this next. All right, so let's do a 10 minutes break. We'll be back at 11:15. I will pause the recording so that if you watch the video, we will see we don't see the break, so that you can just keep watching recording. All right, so there's a great question on chat. Say, hey, does physical memory matter in the case that we have multiple programs running and let's say when we have array, right? The thing in your array is essentially is contiguous, so it has to be next to each other, right? So let me use this to kind of show what is actually going on inside the physical DRAM. And we will not talk about the virtual memory yet, which is what you see in the program itself, right? But let's say you have program A and program B. Program B is run, and whenever it has some allocation, I'll use the blue text. And for program A is orange, right? And in the box here, right? In the box here is, let's assume essentially that's your DRAM, right? It's not a two-dimensional thing. When you look at physical DRAM, when you look at the address, it's one-dimensional. Address 0, address 1, 2, 3, 4, 5, 6, 7. It's just that I don't have the room. So I want to make sure I just draw this box, right, to kind of represent the abstract version of the physical DRAM. So let's say program A wants to allocate a space for its data, right? It wants to allocate a space for its data. And let's say I name this array 1. And let's say the size is like 50. right? What would happen is there'll be a process that the program basically asks the OS, hey, do you have the room for 50 elements of my integer? I'll fit them in my physical DRAM. And then say program B comes in, program B wants another B data. Let's say it's called B data. It's like 100 integer, right? And for the A, it's like 50 integer. Right? And it keep going on and on and on. So A needs this much, and then again needs this much, because sometimes you just create like multiple array, right? And then B comes in and like, hey, I want about this big. Right, so this B data 2. Right? And then A comes in like, hey, I want to allocate a huge chunk of memory too. It's like this big array 2, right? So what can you see here? Are there going to be any problem if I keep doing this? What would be the first problem I would run into? So what could be the first problem I'm going to run into? What if B, yeah, you're running out of memory, but before you run out of memory, do you have area that's unallocated? Like it's not used by anyone, but you cannot fit the size that block in. Is there one like that? Here from this example, we haven't used 100% of my physical DRAM, right? But by this point, we're running out of memory. So this is a problem called fragmentation. Right now, the OS has a really, really good method to handle fragmentation. So it's not a big problem, but you have to be aware they exist. Because when you start to have like big data application, you can still run into this situation, right? The second thing is, what if I run a program, right? And then the first program say, hey, I'm done with this guy. The first program say, I'm done with this guy. So I have this. The blue program say, I'm done with this as well, right? But then I have another allocation come in from the blue program, and it's about this big, right? And the comment, another reason why I like about the question that get asked by one of you guys is that you then basically imagine this is like a Tetris, right? Where you try to fit everything in as much as possible, right? Does it look like a Tetris here? Right? So at the end of the day, if you look at the way virtual memory is managed, right? When you look at Tetris, your shape would look something like this, right? It's basically box, right? That looks like this, like multi-shaped box, where you try to fit things in, right? The way OS is handling things is like these boxes, it actually gets broken down to this like smaller unit. This is called a page, right? And you try to spread out these small boxes everywhere, but there's a way we will learn how toward the end of this semester how to make sure that from the programmer view, right, you still see this whole thing as a unit. This whole thing as a unit that are next to each other. But in reality, right, these boxes might all spread out like one box here, one box here, another box right here, and another box right here. But from the programmer point of view, right, these four boxes is one of the single unit, which is this guy. The thing called virtual memory is one of the reasons why we can do this. So yes, physical memory does matter, right? If you have to work in the area of like, I want to come up with a new system call, new kernel, new way to manage memory, which we have this all the time. I actually basically am working on a few projects that are research project that looks into how to manage this for like mobile phone and something for data center, because we always need a better management. right? We always need a better management. So these are some of the topics that are legit. People actually work on it. I actually also, if I'm pretty active in like virtual memory research, how to make it like cost the least possible. So if you're interested, let me know. Um, I do take interns. Advertisement. But yeah, I do a lot of research in this direction. These are some of the things I find really, really passionate. A lot of my passion goes into these topics, and I have a lot of fun uh, dealing with this. And again, great question. Now we are talking about the pointer, right? Now if come back, let's come back from the question that side topic, uh, and looks at how C store the data. And let's assume that you don't know that answer yet. So every single piece of data or variable that a program uses is going to be stored somewhere in DRAM, right? It has to have a place in the main memory, right? It has to have a place in the memory, and the memory has to manage whenever you want to change the data or you want to store a new value to your variable, right? Each each variable in your program will have an address. Think of it as a home for your data, right? Even just normal. Think of it as like everyone should have a home. No one should be homeless unless you have a really, really bad government, right? No one should be homeless. Yes, you do. Well, assuming you know the situation, with like economy and everything. If you run out of room, then some data will not have a home. But in C, our variable will have our own address. So this is similar to when I want to go to the data inside DRAM. The address will help me identifying where is the location of the data, right? Why is this good? Why is this good? Okay, I guess why is this necessary actually? Why do we need an address for your data? Why do we need a home address? So what's the benefit of having a home address or an address, the concept of an address? What do we use it for in real life? Exactly. From the context of the computer, this is awesome. So that the computer knows where to retrieve the data, right? And the same thing with like human, right? We need an address so that I can go and get to that location, right? Uh, Salaya, for example, has this address so that if you've never been to Salaya before, you look at the address, you know exactly where you have to go to get to Salaya, right? So your data have its own address, your array, because array is a bunch of multiple pieces of data, right? It would then have uh the range of address, and hopefully the range doesn't overlap, right? So hopefully you don't write into your friend's data. So unique data should have a unique address. Also in C, you can create the data type that store the address. So instead of storing the data, you store the location. You store the location. We call this pointer. So now let's look at some of the differences. So in A equals 10 means that A is a variable. The data value of A is 10. So the value of this is 10. If I put ampersand, it means I want to make a reference. I want to get the address of where this value 10 is located in DRAM. Ampersand A will get you the address. So technically, this is virtual address. We're not going to talk about it until module 4. It's not the actual location of your data. You need the physical address for that. We will not talk about it yet. But ampersand A will give you an address for this guy, right? And let's visualize this, right? So let's say you have DRAM that's like gigabytes of DRAM. Your DRAM will start from address 0 and it would have, let's say it's 4 gigabytes, so address will be like 4 what's giga to 10 to the 9, right? 10 to the 9. So it's 4 multiplied by 10 to the 9. So that's the last address. And let's say you store the data 7, you store the data 7, number 7, at address 100. At address 100. And I store this as a 4-byte integer, right? Because data has a size, right? Let's say I use 4 bytes for that. It basically means that that block will be 4 bytes in size. Inside them, you see the value 7, literally like 0, 0, 0, 0, 0. So like whatever binary is represented by 7, which is 1 on 1, right? So over here will be 0. A bunch of 0 and then followed by 1 on 1 at the end. Literally, it will be like that. Store the binary representation of the number 7. Unless you have another data value 5, right? Right next to it. Can someone tell me what will be the address of this guy, number 5? What should be the address? The address is byte addressable. So if you go to address 101, you will actually get right here. This is address. Oops, really bad choice of color. Address 101. So it's 104 because your data is 4 bytes, right? So 100, 101, 102, 103 belongs to that guy that has the number 7. 104 will be where the number 5 begins, and it will cover 104, 105, 106, and 107. Again, 4 bytes, right? So if I have another number 5 in there, so now let's say my array is basically this, right? Array is 7, my bad, 7, 7, 5, and then 5, right? Then you put next to it array 108, address of 108, another 4 bytes, right? Any questions so far on how address works? This is basically how address works. If I go to ARR of 1, what will I get? ARR of 1, what's the value will I get? What's the value? Value is 5, right? Address is 104. Right? It's as simple as it's a way for the DRAM to store the data and for the OS to govern how data should be managed and stored, right? How data should be managed and stored because it's simple. You just have this 1D address, right? And you have data coming in to give them the room, they'll fit in there and they'll live there, right? So now, if I want to access ARR, I can use 2 things, right? The first thing I can do is to access, right? I can use variable name, which is literally ARR of 1, right? I can use the address of this guy too, right? Which is 104. If I try to access and tell C program, say, hey, go access address 104, you will get number 5. And there are ways to do that. So we will now move on, right? We will now move on to how do we use it. So we can use pointer for that. So let's say I do install. So this will not compile. I don't have the room. So in reality, we will do this in star A to create the pointer name A. And then I can say star A equals malloc size of int, right? We'll talk about malloc in a bit, but malloc basically means that go to DRAM, find an area of 4 bytes for your integer, and give me my free LAN so I can store something in there. And it's actually A equals malloc, not star A. And then I can do star A equals 10, right? So it's a 3-step thing. In this case, A is a pointer. A is a pointer. And the reason why they are named pointer is it points to a location. It stores the address. The address points to the location that has the data value 10 right now. So star A will get you the value 10, but A will give you the address. A will give you address. And if you have a variable that's not a pointer, if you have a variable that's not a pointer, you can use ampersand to get the address. So you can do something like this. Now you have int star A, right? And then you say int b equals 20. Then I can do this. A equals ampersand b. This means that A will now point to the same address where B is located, right? You can use star on a pointer to get the value like this. This would give you the value, and you can use it interchangeably. You can make pointer points to other variable, which I just did here. Pointer points to the location of B. You can also do operation on the pointer, which is, for example, a plus plus, right? A plus plus. So over here with this example, what's the type of A? What's the type of A? A is a pointer, right? To an integer. This is important. It's a pointer that points to an integer. So that's the type of A. So if I do A plus plus, and let's assume, right? A is 100. So let's say A is 100. What is A plus plus? Will I get 101 or 104? Again, A points to an integer. A plus plus will go to the next integer. So am I going to get 101 or 104? So 101, will 101 get me to the next integer, or will it still will I get stuck at the same integer with 101? Because address is in byte, right? So 101 is byte 101 in your DRAM. So yes. So if I do A plus plus, I will move 4 bytes, which means that at that time I should be 104. So A plus plus will give you 104 because integer is 4 bytes. So the A plus plus go to the next integer. Basically, it means that I will go to 104. All right. So you can do pointer arithmetic. Now let's say I have something like this. Char star C, right? And then I say char star C equals A. Now, what is the value of C? C is a pointer, so is C 100? So let's say A is 100. At that point, C is going to be 100, right? So what if I do C++? What happened? Will that be 101 or 104? So if A is 100, I point C to A. So C has the same value as A, and then I do C++. But C is a character pointer, so it points to a character. So if I do C++, in this case, it's actually 101. Because the amount of bytes that get increased depends on the pointer type. Over here, the pointer points to a character. A character is only 1 byte. So if I want to move to the next character, I will then point to the address 101, not 104. All right, is it more clear now? I want to make sure that it's not it's less confusing. All right, so shall we do this again? Shall we do this again? All right, awesome. So do you mind if I erase the ink here so we can actually let me do this. Let me make a new slide. The annotation and All right, blank slide, right? So let's say this is my, oops. This is my DRAM, right? And let's say this is my array A, right? So I can use star A, right? It's a pointer. Let me do this, right? It's an array with a bunch of number, right? 7, 5, 6, 3, right? And I have a pointer, which is int star A char star B. Is both of them are pointer. I just declare that I have a pointer named A and B. And let's say both A and B points to this location. So A points here and B points to here, right? So what is the value of star A? If I do star A, what is the value? Star A is going to equal 7, right? Because it's an integer. 7 is also an integer, so it points to the integer, and then you get 7 back, right? Are we, at least at this point, is it more clear? Is it clear now about A? All right, so if I do star A plus plus, this means that I first increment A, and then get the value. What is the number? I first increment A to move to the next item and then gets the number. So this would be A plus plus. We'll have this action. Yeah, so plus, I put the parenthesis around it so that the A plus plus would happen before the D reference. So we move to A plus plus, then D reference, because I put the parenthesis around it. It worked the same way as a math, right? So if you put parentheses around the operation, we do that first. So this will be 5, right? If I do star B, it's not going to give you 7 because here's what happened if I do star B. It will only take the first byte in here. Whatever is in here, this would be your star B, right? So depending on how the data is organized, right? Whether the 7 is in the byte 100 or the byte 103, because the rest are going to be 0 because my number is really small, right? 7 is just a bunch of 0 at ends with 111. So star B can have the value either 0 or 7, depending on how you organize that number. Some machine would put the lowest information for like lowest bits first, so 7 would be on the byte 100. Some machine would put the number 7 on the byte 103. I should not have done this because we talk about this concept called endianness after the midterm. But now, for now, just understand that when I do star B, it's only take the first byte here at byte 100, right? So star A would get byte 100 to 103 because I get 4 bytes. But star B would only get byte 100. So if I do B plus plus, which byte are you at? 101. Yeah, so that's the point I want to get across. Is it more clear now? Awesome. All right. So what about an array? When you declare an array, technically this is a pointer. So array is pointer. It's just that for your array, you have the range already. So it's predefined and it gives you the whole block already. Array of integer with 4 elements is the same as a pointer that can move up and down this range. Basically things like A5, like you go to the 6 elements of A, like A0, A1, A2, A3, A4, and A5. So A5 is the 6 elements of A. This is similar to I do this. I have A, which is the first element. I add 5 to that, so you move it 5 times and you dereference. ampersand A5 is also going to be the same as just A plus 5, right? Any questions so far? Basically, you can treat array as pointer. So let's say you create an array of 10 things. You can do A plus 1, A plus 2, A plus 3, A plus 4. We'll move up, and down that range. All right. And then there's a concept of the null pointer. Null pointer is basically mean the pointer that doesn't point to anything. It's a pointer that doesn't point to anything. For example, if I just do int star temp, right? I can do temp equals null. So let me start to brainstorm a little bit. Why is this good? Why is it good that uninitialized pointer points to a null location, which is this is not pointing to anything yet, compared to I assign random value for my pointer. Which one is safer? Which one is safer between I create a pointer and let them point to a random location, or I create a pointer and make sure that thing is not pointing to anything yet? So it should not point to anything, right? It does not actually save the space for the pointer creation itself, but it is safer in a sense that you don't randomly point at someone else's data, all right? Because this will prevent you from randomly pointing at someone else's data, or even your own data that you're not intending to fix or modify, right? So usually when you create a new pointer, make sure it's point to null, and you can do something like this. If temp equal null, right? Then you do something when it doesn't point to anything. You basically can have a code that handle that case, and then else, right? This is like a classic thing you would usually do with pointer. Check if you point to null location before you move on. So in C, you can assign null to a pointer value. This means that it doesn't point to anything yet. Accessing the value will generate the error because you are basically trying to dereference. You try to get the value of something that's not pointing to anything, right? And then data type, each data type has its own size, right? For example, in the modern day C, right, integer is 4 bytes. You can have a short integer, which is 2 bytes, or a long integer, which is 8 bytes as well. You can have the character, which is 1 byte. But this depends, the size sometimes depends on the generation of the compiler and the generation of your chip. So to make sure that you get the right size, use size of and put in the data size. Size of A, for example, would check the type of A and will give you the size of that particular data type. Size of float will give you the size of floating point. Size of int will give you the size of integer, right? This is for just to make sure the code is safe. The code, you know exactly how many bytes you are handling. Star is an operator like in star, star A, right? This is an operator like add and multiply, but it's a singular operator. It takes in only one input, which is a pointer. The process is called dereferencing. You have a pointer and you dereference to get the data. Ampersand is called referencing. You have a value that has the address. You create the address, right? So what does this do? What does this do? You first reference and dereference the same thing. So what does this actually do? So you first dereference A and reference it back. It doesn't really do anything, to be honest. This is A, right? It deal with the address. For example, you create the address and you say, hey, let's get the data from that address, right? So this is what happened. First, get the address of A, followed by then get the data of this address. So star ampersand A is gonna equal A. All right. Are we all on the same page here? Basically, it's do nothing. It's A. It does two things, which result in the same thing. It's not that it's doing nothing. It do two things. You reference and then dereference, but it results in the same thing. So things to be careful when you're using pointers. We will show that in the exercise and the demo. Make sure you first declare them. These are all common mistakes for your assignment 3. Make sure you declare them. Make sure it points to the valid location, either to a null address, to a variable, to allocated space. Otherwise, the location you're pointing to is illegal. Think of it as you're walking to someone else's home, right? You're walking on someone else's home, which is a bad thing. It's illegal. You're not supposed to do it. Cops can come in and arrest you, right? Now, because the assignment 3 would ask you to also handle like file as an input. So we can use the file pointer for that. The way it works is, so let's say I can do file followed by, right? This is a data type. File is a file pointer data type. So I can do file star fp. I can just name my pointer whatever names I want to, right? And to open the file, I can do fp equals fopen. And then here's the name of the file, right? File name. And then here's the mode. Mode can be read, for example, I put in the letter R, means that I want to read from the file. R mean read. W mean read, write, right? I want to write to the file. And when you're done, close it. Close it to make sure the OS actually properly close out the file. You can check out how to use it here. If there's an error, fopen returns null. And you can use this to read from a file. For example, when you do scanf ampersand A, my bad, sorry about ampersand, you can replace scanf. Oh, let me fix it right now, actually. My bad. I should be fixing this right now. So scanf ampersand A, my bad. I can replace this and read from a file by scanf, right? Scanf. So there's an F here. Put in the file pointer so it points to correct file, and the rest are the same. You can also use the same for get C and get S as well, right? And you can also then, this is reading from a file. You can also write to a file from, instead of printf, you do fprintf using fprintf file pointer. Like earlier, we used fp as a name for the file pointer, right? So you can do fprintf and then fp, and then this is writing a file, right? So I can do hello, right? And this would print the word hello on that file, right? And when you want to keep reading file, you have to deal with the end of the file. It's a special symbol. You can use the function called feof to check. So things like feof fp will return true if this is the end of the file, false if not the end. False is not the end. So usually the trick is something I would do all the time, which is something like while, right? Not feof, and then the file pointer name here. And then over here, this part you can just like read the file, right? Basically, this means I'll keep reading until I reach the end of the file, right? So I can keep doing that. Because file is a stream, right? So stream IO is basically a type of data that handle things from the type of like things like file, printer, terminal, keyboard, inputs, right? You can use printf. This is normal standard input output, your keyboard and the monitor. Fprintf for the file, and sprintf for the stream. We don't have time to go into the detail of the sprintf, but you can take a quick look at that in case you need that for the future if you have to play with streams. The concept of stream, we'll kind of dig through that in more detail when you go to functional and parallel programming. All right, so now let's take a long break so that we can do lunch break before we come back at memory allocation topic. So let's resume. Would 12:35 work for you guys? So we do a 40 minutes break. In the middle, I'll be here. So if you have questions, it's fine. I'll take questions and I'll answer them. All right. So I'll be here to basically answer all your questions. We resume at 12:45, and I'll stop the recording so that if you watch the video, it will just resume right back. All right. Resume the recording. Okay, so now that we're back from a longer break, we will resume and talk about the next concept. Well, it's a follow-up to the earlier concept of pointer, right? Which is memory allocation. Why do we need one, and what's this for, right? So when the program begins its execution, data actually take up space, as I showed you earlier, when you have the DRAM and you need the space for your data, right? The program basically allocate the memory for the variables that you use in the program, right? It would also allocate a block of memory for your array. But with the concept of the pointer, you can also manually allocate the memory for your pointer. And there's a function call for that in C, right? So how can you allocate the memory? So static memory allocation is done through an array, right? Something like int A10. It basically means that the OS go and find free space for 10 integer and give the program back those empty space that you can use later. So that is static memory allocation. Why is it called static? What's the size of A10? How big is this array? So how big is, what's the size? How many integer can I store in this array A10? So you can store 10 number, right? The size is 10. Dynamic memory allocation works this way. You can use the function called malloc, right? And that actually has to be quite a bit of the code to manage how malloc should handle allocation. But essentially how it works is, in this case, you can put in the size as an argument. So this is a size in byte into the malloc call, right? And in this case, it's 10 multiplied by size of int. It basically means that I want to create 10 space for my integer, return the beginning of that space to array A, to A, so A will point to this location. And then you have the space for 10 integer. So this command basically go and find the free location in DRAM, allocate this location for pointer A, or think of it as a system go and find the empty land that you can fit 10 integer for A, then A would take this address. So here's an example that visualize this process, right? So same example, we have n bytes DRAM, right? And then I call x equal malloc size of int multiplied by 3. When I call this, it's basically make the empty space for x Right? For X itself, let's say this address 100 again, right? Almost the same example. Because I want three integer size of int multiplied by 3, I will basically create three empty boxes where you can then use later to store something in there, right? So now we are just done with the creation and the allocation. I found three spaces for X. Each of these boxes is 4 bytes for an integer. Now let's say I do star x equal 2, what will happen? If I do star x equals 2, then you basically want to write the number 2 at the location 100, because right now x has the address 100, right? So x equal 2 would write the number 2 in there. So what if I do x plus 1 equals 4? Can someone tell me what would happen if I do x plus 1 equals 4? Then the number 4, the actual value 4 would be put in the next box, right? Because x plus 1 would be address 104. Address 104 because the x is address 100. X plus 1, you move one box. One box is 4 bytes. So you go to address 104. That address will now take up the value 4. And then if I do x plus 2 equals 8, in that case, then the number 8 will be put in the location address 108, which is that next box, right? So this is how allocation works, and also how dealing with like the pointer after you allocate. So now you can create as much space as you want through the command called malloc. And this is a nice thing because you can do dynamically. You can do this dynamically while you're running the program, right? So let's say you create an array and then at some point your array is full. How many times you run into the case where you write a program and your array becomes full? You need more for your array. This is a possibility, right? You can keep writing a program and at some point your data cannot fit in the array and you want to double the size. For example, you want to create a bigger array. You can use malloc for this, and the step is simple. First, you would create a temporary pointer, right? And then you allocate a bigger size range with this new pointer. Then you copy the content of the old pointer to the new pointer, and then you deallocate the old pointer. Then you copy the address of the new temp pointer to the old pointer. So we will do this for your in-class exercise, right? You'll do this for your in-class exercise, and it will be a part of your assignment 3. This is something simple that we would like to make sure you can do, right? So again, the step is simple, right? So let's say this is your pointer. Let's call it PTR, right? Point to this location. And right now it has 4 number, 4, 7, 3, 5. And it's full, you want to add more. You basically want to create a bigger array, right? This is a step. So the first step is I create a temp pointer and then I malloc them. Right. For here, let's say I want to double the size. I want you to basically malloc for 8 multiplied by size of int. So you basically get a temp array, right? Temp point here. And you have 8 slots for your number. That's the second step. You create a temp pointer. Then you copy the content. So 4 get written here, 7 goes to here, 3 goes to here, and 5 go to here. So you now copy the content of the array. Then you deallocate. This is done by the command free pointer. It basically would return this back to the OS, say, hey, this is free, you can use it later. I clear up this space, and then make sure now pointer, what you can do is then do pointer equals temp, which force pointer to point to this guy. And now you're done. Okay, now you're done. And again, because we have the command called free, this is called memory deallocation. This is some of the thing that you might run into when you forgot to free. There's a problem called memory leaks, which means that you keep asking for more and more and more and more. And when you're done using your data, you forgot to free. So when you no longer need to use the allocated memory, you need to deallocate, which means that you're going to mark the region as free. So anyone else can now come in and use it later. This is done by calling the function called free, followed by the pointer name as an input. And you need to do this to avoid memory leaks or your computer will run out of memory. This actually happened to my, like, there was a time I was in the lab working on my PhD project, right? And at some point I forgot to free. And then my friend came to my cubicle and yelled at me. It's like, hey, Rashada, what did you just do to the lab machine? Because now I run the experiment on everyone's computer in the lab because that's what we do all the time in our lab, right? And most of the time it would work. Like people can run things on my computer. We have set up for that. But then I have memory leaks, so now all my friends cannot use their computer because they run out of memory. So I need to fix it, kill all the process that have been running, and then fix the program, right? So these are something that can actually happen to you as a developers. Heap versus stack. We'll talk about this in more detail when it goes to module 3 assembly. But pointer can point to either the heap or the stack, which is a part where the OS managed and use a different way to manage it. The stack is used where you know the size of allocation beforehand, things like normal variables or arrays or essentially any static memory allocation. And for things like malloc, usually this is called through the heap, right? So it's a different region in your DRAM. This allows the OS to kind of like have a different policy to manage the stack and different policy to manage the heap. For example, when you have function call, you have to allocate things on the stack rather than the heap, right? So the use of pointer, as I said, you can use it for memory, dynamic memory allocation, have a extensible array. For example, you don't have to fix to like an array of size 10, arrays of size 100. Now you can make array of bigger size using pointers. You can implement data structure. So if you are in the DSOOP class or you plan to take the DSOOP class in the future, you can implement these data structure that you learn in DSOOP inside C language through pointer and struct, right? Basically, struct create the basic one single item and then use pointer to link them up into a form of like linked list, for example. So we will teach how linked list is managed and done. So this is the part we will be teaching you for sure. That's coming up next week. We will not talk about the tree, so those are in DSOP. We can use pointer to pass data into function and pass data out of the function. For example, let me ask you this. When I have a return, right? When I do return and then something here, right? How many items can I actually return? How many items can I return? I can only return one thing, right? Are we all with me so far? Basically, when I call return, I can only return one single thing. What if my function want to output the 2 or 3 different things? I want to update 2 different pieces of data. Then you can use pointer to pass the data out of the function. We'll show you how this can be done in one of our example, right? You can return more than one items, pass the data out of the function. You can also use to assign pointer to the function. We'll get to this in the bit, which is more thing to consider here, right? First, sometimes you use a pointer and you have a pointer that you created, but you don't know what should be the data type yet, depending on the program. Depending on the structure of the program, sometimes if certain thing happen, this pointer should point to an integer. If some other thing happen, this is a pointer to a string, right? It's an array of character. So a void data type is legit. It means that it's not pointing to it can point to something, but I don't know the data type yet. A function can have void, for example, as a return type. Void means nothing. Void as the data type means that there's no type associated with it. It means that the function doesn't return anything. A pointer can also be a void type. It means that it doesn't have any particular type yet. It points to an address, but I don't know what's the data type for that address. Then you can cast the type later. This can be also used for function pointer as well. So here's how casting can be done. Similar to variable, right? You can use, you can cast a pointer type and cast a pointer type. int star means that I'm going to force this pointer to be an integer pointer. For example, let's say I do char star ptr, right? But afterward, I do int star ptr. It means that now ptr would take the type integer pointer for that line. Basically, I cast it as an integer pointer rather than char character pointer. So float star means that this pointer will now point to a floating point number. You can do the same thing for any type of pointer, right? Now we are done with pointer. The next thing we have to talk about is constant, right? Constant. It used to declare that the variable will not be changed. For example, if we do const int star a, means that a can point to many things, right? It's just a pointer. It can point to many things, but you as a program right now that I declare a is the integer pointer, but is not going to be modified. So I cannot use this particular pointer name to modify the data. So I cannot do something like this. I cannot do something like star a equals 10. It forced this to be read only. It forced the variable a to be read only. You can point to many things, but you cannot change the value. You can only read from it. Const a, like install const a equal ampersand I. In this case, you can change the content of a that it points. Like you can change the location of that address. You can change the data, but you cannot change where a is pointing. So right now, a is forced to point to I. A is now forced to point to I, and it cannot point to anything else. So if I do const install const A, it means that it's read only, and it only point to one single location. And you can also use const on a function declaration as well to make sure that you cannot really like modify the function. And the function is a constant, right? So that's it about const. The next thing I really need to talk about is the GDB or the debugger tools. This will be useful for assignment 1, assignment 2 and assignment 3. GDB can be invoked by adding the -g, right? So you can do gcc -g test.c. It would create the executable, like the program that you can run, but that program becomes special because you can then run gdb and then the executable go here. For example, gdb a.out, and I totally encourage you to Google gdb cheat sheet, and then we'll do some example on Monday. So when we go through some of these examples on Monday, I will show you how GDB is done. I'll record this so that for those of you who don't have the time to attend the Monday slot in the beginning, you can watch the video. I'll just show you how GDB can be done and how to, I guess, debug your code, right? The next thing that is today a lecture on the midterm? Yes, it will be on the midterm. You should expect to either modify existing code or write some code, but it should not be as long as the assignments. You will have the starter code. Next week it will be actually the last one on the midterm, the beginning part of next week. Actually, let me see if I can finish everything for today, because I want to cover how linked lists can be implemented, which I don't think we'll have time for today, but the first hour of next week should be a part of the midterm. And if you're curious, I will point you to the video from last semester that talks about linked lists. So basically, this is the last topic about pointer. Feel free to go ahead and watch that. We'll cover that next week. All right. Now, the last thing I want to cover today is a function pointer. Pointer can point to value or data, right? Because your program, when you run, the program is also in DRAM, in your memory. It means that I can use pointer to point to the function. Yay. I can now use a pointer to point to the function. Why are they useful? For example, let's say you have function called a. and function called b, right? And depending of the condition of the if else, right? So let's say you have if else. So if this is true, run function A. If this is false, run function B, right? One thing you can do is to make sure if this is true, you have a pointer to point to function A, right? Pointer. Otherwise, this pointer will point to the function B. And this is a little bit more flexible comparing to when you have the code that are built in statically. It's like, hey, run function A and run function B. Now you just say, hey, this pointer would point to function A, and this pointer would now point to function B, and you can use this pointer all the time. And in the future, you can use the pointer later, right? Pointer with the input to call the function, right? Again, this is one example, but generally, because functions are just instruction of add, multiply, create an array, go through the array, increment everything in the array, or do the summation, right? So your program essentially is stored in the memory. This means you can use the pointer to point to them, right? You can use the pointer to point to them. Function pointer can be used to do this. Here's one example. I have a function called func that only what it does is it adds 10s to a and return, right? I can create a pointer called funcptr. This is the function pointer name. Right? And let's crack this one at a time. What come up, because I do star funcptr, that's a pointer. That's the name, and that is a pointer type. It points to something. Takes, this something is a function that takes one integer as an input, and it returns an integer. And then I force this to point to my function called func, right? So now func pointer points to this guy, which also match the signature. I take one input as a number, I spit out one integer as an output. And to call the function, I can then do this, star funcptr0. I first dereference, right? Dereference func ptr. So from a pointer which store the address, it store the address of where that code is located. I dereference them to get the function. I put in 0 as an output. So this will get print. What will get print actually? Now I put 0 in, I call it twice, I print %d%d. So what should I see as an output? What should I see here as an output? So I have 0 as an input to my function. What does the function do? Add 10 to that. So the output is 10. I call the function twice, so it should be 10 colon 10. What we get print is 10 colon 10, right? A quick note on function pointer. First of all, you don't have to malloc because your function is already in DRAM, right? Program are already allocated and stored in DRAM when you run the program. You can get the address of a function using the pointer. Basically, you can use the pointer to get the address of a function. Basically, now think about bad things you can do with this, including things like buffer overflow, right? So pointer can also be an array. This means that you can have array of function pointers, and it operates like a normal function calls. Many C library, which will show you through one of them called qsort or quicksort, this allows you to sort the element in your array. Yes, I'll explain the function pointer again with the number. And you can use it as a callback function. And here are some references, right? And here's a sample code. So I hope this is more clear. Can I use sample code for that to explain function pointer? All right, awesome. Yeah, sorry. So one thing I've been doing while you're finishing lunch, right, is I was creating. So this is on a server. Can you see the screen? Awesome. So I create a few things, right? So because we just talked about function pointer, so let's go with qsort first, right? I just go now qsort. I do include standard IO and I include standard library. The reason why I include standard library is qsort, which is the function called qsort. And it does take some inputs. I'll show you how inputs is it actually how to do qsort. This is perform quick sort algorithm to sort your array. To sort your array, you can do it to make sure it's from small to big, big to small, depending on how you define it, right? And the way qsort works, it's something like this, right? So let me go back to this here. The qsort function takes in your array, number of things in your array, the size of each item, and the compare function. So we will take notice to the last thing, right? The first three items is simple. What's the name of my array? Can someone read this code quickly and tell me what's the name of my array that I want to sort? Yeah, array. I want to sort that guy up top, right? What's the size of my array? How big is that? 10, right? The size of each item, how do I do it? Size of int, right? So that's the third input. Again, let me switch back quickly to this slide. It takes 4 inputs. The array, the size, how many items are in your array, what is the size in byte of each item, and the last thing is a compare function. So we are done with the first 3 things. Any questions so far? We are done with the first 3 things. And now over here, I put in the comments because I want to make a note. Somehow this has to be a function pointer to point to a function that can be used to compare your data, right? Let me put the comments on the top to make it more readable, right? So are we clear for now? We will now talk about that last thing. And we want to use this compare, this function called compare, to behave like a compare function. And the way qsort works is this function should return -1 if a is less than b, and 0 if a equals b, and 1 if a is greater than b. So are we clear with the properties? So basically, this should be the properties of my function call. If I want to say I want to sort from lowest to biggest, right? The way the comparison function works is if the first number is lower than the second number, I want to return -1 or negative number. If it's equal, it should be 0. If it's bigger than the second number, then I return 1. Any questions so far? Any questions so far? About at least things we want to do. Okay, so far so good. Now let's build a function pointer. Can someone give me a name for the function pointer? Any name is fine as long as it's a legit like variable name. And as long as I can use the name, obviously on the video. Okay, right? So this will be my function pointer name, right? Again, it's a function pointer. I need to make sure I do start, right? So usually pointer should look something like this, right? In star and then the name. Right? This is like normal pointer, right? It points to one integer, but over here in this case, right? I want my pointer to point to the function. So how do I do this? How do I change from a normal pointer to a function pointer that points to the guy up there, the compare function? Here's how I can do it. First, this will declare that RSCH is a pointer. It will declare that RSCH is a pointer. Right now, still, this is an integer pointer because I haven't finished everything yet. If it's a function call, it has to take some input. The input to the function call will go into the parentheses right after the function name. Over here, right? You have parentheses come right afterward. Can you look at the function signature and see what's the type of the first input? Can someone tell me what's the type of the first input of my function? Well, the type of my input for my compare function, I take in two things. It's a pointer, it's const void star, right? It's const void star. All right, we will handle that later. All right, for now, I just want to make sure everything match. Does the return type match already? The return type is integer, right? So my return type already is okay. Right now it's already return integer. Now I just create a function pointer that point to, if I can use this function pointer to point to any function that takes in two inputs, which is a const void star, return an integer afterward. So over here, right? Because I'm done with the function pointer naming, right? I can do this. I can do this. So that's my last input. I just put in the function pointer. Everyone, are you with me so far? Basically, I'm done with the main function. I just name a function pointer. I haven't done anything with the point to the correct function call yet, but the Q sort is almost done. So over here, what's the next thing I need to do? I need to make sure Raj, right, points to the right function call. So what's my function call name? What's the name of the function that I want to point to? Compare, yes. Because the function definition is called compare. The correct function call that I want to point to is now called compare, right? As long as I have this, it means that when I have Q sort over here, when I'm on this line, when I am on this line, this Q sort array 10 size of like this line, right? You see my cursor, when I'm on this line, I will call the compare function. Q sort will have the pointer that points to this compare function. And if internally Q sort will keep calling this with its own input, we will keep calling this with its own input depending on how it used the compare function, right? So it's fine as long as I now compare correctly. So how do I implement this function? How do I implement this function? So if something return, right? Return -1, else if something else return 0, and else return 1, right? And just to make your life a little bit easier, so let's say int input 1 equals something, int input 2 equals something based on A and B, right? So this will be something based on A. So basically, this is what we want to do. Basically, get the value of A. Right now, A is an address. And over here, and basically we need to get the value of B, right? And if A is less than B, my bad. If input 1 is less than input 2, return -1. If input 1 equals input 2, return 0. I also return 1. Are we clear so far? So now if we finish these two lines, we are done. We just need to make sure our compare function behave correctly. I need to dereference A, convert to an integer, compare the value. If it's less than input 1 is less than input 2, return -1. If input 1 equals input 2, return 0, otherwise return 1. All right, so how do I get the first thing? Right now it's const void. A is a pointer that has no type. What is the type of my number? Can someone tell me what's the type of my number? So it has to be something based on A, and this has to be something based on B. So how do I first get the correct type? Well, you cast them, right? From when you do this, A becomes int pointer. So A changed from void pointer to int pointer. So what do we do next? It's a pointer. How do I get the value? Close, actually. A is a pointer. To get the value, I do star. If A is the value, if it is a variable, then I do ampersand to get the pointer. So it's the inverse of ampersand. That's the star, right? Again, B, right? Another practice, I do int star, right? To cast it from void type into integer type, and then I dereference to get the value. Is it more clear now? So input 1 should be a number that A points to. Input 2 also should be a number that B points to, and we just compare the two numbers together. So let's say A point to this guy, 78, B point to 12. You can then, when you do int star A, cast it to star again to dereference to get 78 and 12. You get 78 and 12. So now let's see how this will run. All right, error. I forgot the sorry. I forgot the semicolon at the end of my printf here, right? And I think here. And let's see if there's anything else. All right, so let's run this. Before sorting, as you can see, we have this number, right? 5, 2, 78, 12, 5, 34, 82, 3, 34, 3, and 20. After sorting through Q-sort, you see now that all the number is now sorted from biggest to smallest, right? So now let me do some quick thing. Let me actually now, with this program, right? But I want to, instead of doing smallest to biggest, I want to do biggest to smallest, like sort, compare big to small, right? With the same function signature, const void star A, const void star B, right? And instead of having this return that I say earlier, this guy here, right? These three lines, I want to now sort from smallest to biggest to smallest. So if A is greater than B, I want to return -1. If A is less than B, I return 1. Right? So to do this, one thing I can do is everything here looks the same, almost the same, right? Here, right? I extract the value of input 1, I extract the value of input 2. What do I change here? I'll go back to your question quickly, but now let's finish this part first. I want to sort from biggest to smallest. So over here, if it's greater than input 2, return -1. This thing is the same, right? If it's equal, return 0. Otherwise, return 1. So now, instead of pointing my rush pointer to compare, what do I do now? So instead of this line, what do I have to change? Compare big to small. I just make it point to a different function and I'm done. and I'm done now, right? So let's compile and run this program. Now you see now it's sorted from biggest to smallest. So as you can see here, this is pretty convenient. You can now build multiple function calls, right? And depending on what you want, you can change just one line, point to a different function, and we are good. Everything behaves the same way. Now, that's another good question. I'll go back to that. But first, there's a question to say, why can't we just take an integer to the function is a void? That's also possible. So if I do this, right? Let's say if it would compile if I do this. Right? Here. It would warn you because of what? Q sort over here that we have, right? First of all, my function signature say I want const void. So the next thing I have to do is to make sure function signature here match, right? And then it will, here's the fun part. If you go to standard library and look at how qsort is implemented, right? Because when you implement qsort, when the guy who implement qsort built the function call, can he tell that it's going to be an array of integer, or do I have to build a function work for every single data type? Right? So now, how can I ensure that it's work for every single data type, right? Then the safest things I can do is to assume the user know the function signature. So if you check out the documentation for qsort, it does take in this const void. And it assumes that it's a job of the programmer who want to use qsort to do these two lines afterward. All right, so that clears out that first question, right? Now the next question that you have is, why do I do a.out, right? It's just that when I do gcc, that compile my C code, right? I did not specify what the output file should be named. I can do this like qsort, I guess qsort exbc. If I do this, you'll see that that's a new file called qsort exbc that I can run. So again, it's just a matter I didn't put in an option for the output object file, right? So in this case, I can specify that too. By default, because the command doesn't, because I haven't told you, I haven't told the program to compile and build this executable with this name. It would just use the default name, which is a.out, because why not, right? It's just the simplest name. Yeah, a proper program, when you go to work at a company, make sure you have this -o. I guess it's my bad habit when I'm doing a lecture because I'm lazy. But usually when you work at a company, make sure you put in a meaningful name. All right. So I guess I've removed it out, remove qsort executable. Oh no, not qsort. Oh. All right, so that's our first example that has to do with function pointer. Now let me go back to the lecture slides quickly, because these are some of the manual and libraries that you can check out for the standard libraries and for the C manual, right? Sample code time. So we will do. We have done this, right? This is in class. Well, I guess we might be extending this, so it'd be like take home quick exercise before we go to the makeup class on Monday. Make an extensible array using pointers. So I have some starter code for you. So I'll put that in the. I'll finish up the starter code and show you how a header file works. So it will be an example with a header file. I can use pointer instead of array, and I can swap to value using a function call and a pointer. So let me first go with the first one, swap.c, right? I pre-built this while you're taking a break. I basically type this out. So right now it's a function called swap, right? And swap takes in two pointers, A and B. And I have A and B initialized to 10 and 20 just for the sake of simplicity. And you can read the code later. And the code is just print two things. Before swap, A is equals what, B equals what. After swap, A equals what, B equals what, right? And I call this function called swap. And the behavior that I want here is I want to make sure A and B swap the value, right? The first thing I need to fix, wrong variable name because capitalization matter. Over here, right, I can do int temp equals star A, right? I have a temp equals the value that A points to. Star A equals star B. Make sure the first number point to the second number. Star B equals temp. And we are done. Right? Because usually when you do a swap, it's usually something like this. Int temp, right, equals A, then A equals B, and then B equals temp, right? This is like a normal swap. I change the value. I first store temporary value for A, make sure A equals B, and then B takes the value of A. But now it's a pointer, so A and B are pointer. I need to first dereference them. I first need to dereference them. But the beauty of using the pointer is this. It's an address, right? So temp start here, you pass in the address. So A and B, which has the address right here, right? A and B has the address right here and has originally has the value 10 and 20. When you fiddle around with the address, they actually get swapped on the memory, right? So when you compile and test it out, right, you see that after the swap, A and B exchange the value. So let me clear up the printing so it looks a little bit better. I add the new line in. You can now see that it does get swapped, even though I run the function call and my function call doesn't really return anything. So over here, I don't need integer actually. I don't have to return anything. I just take in the address and you fiddle around with it already in function call. That change get propagated to the main function because they have the legit address, so the address gets swapped the value, right? So that's the second example. Now we can use pointer instead of array, right? So I guess I'll just use this example, extensible array.c, right? And then let's say I create this int a my array, right? The size of 10, right? Actually, let's do this. Star A, R-A-Y, right? And then A-R-A-Y equals malloc. Int, right, multiply by 10. So I need 10 items for this. And then count, I guess. I just need something to count with, right? So I just create some counter, and for count equals 0, count is less than 10, count plus plus, right? This is what I can do, right? So I can do this. Here is what I can do. I can print. Right? First, let me actually assign something like this. Array count equal count. Does this work? Can someone tell me if this would work or not? And at the end, I need to make sure I don't forget free. Can I do this? And then I guess in the loop, right? So I create an array using the pointer, and then I use array as if they are normal array. Is this legit? Is this okay? It should be okay, right? This would be okay. So I can do printf, right? So this is definitely something I can do. My program does nothing except initialize my array content with like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then print them out. Right? So if I do GCC extensible array.c, right? First of all, again, forgot semicolon. I do this all the time. I'm sorry about this, folks. Here. All right. And I forgot to include one more thing. Because I use malloc and free, I need to include that. All right, so no warning, right? If I run a.out, which is that program, it's just data content 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is okay. How about this? How about this? Does this work? Can someone tell me whether this would work or not? I have a pointer called array. I do pointer arithmetic. I just add like count to my array dot plus count, and then I assign the value of that. Does this work? Does this work? It should work, yes, right? So this should work. And it should behave the exact same way because again, array pointer. Basic array is just a pointer, right? I can also do this. I just make array like an actual static array with size 10, right? The only thing I need to make sure I get rid of is like, because it's a predefined array, I don't have to free at the end. I don't have to free at the end. But, oh, and also don't have to malloc. My bad, sorry. Don't have to malloc, right? And then it would work the same way. I can use the pointer and array interchangeably, right? Now, let's go with your in-class exercise. I'll build a starter code for your in-class exercise. So again, I'll show you the example header file, right? I want to make sure I create a function called double the size, right? I guess void double the size, right? That takes in your array and then the size of your array, right? So that's a header file. The header file purpose is basically to tell, hey, in this program, there will be a function called double the size. I am not going to implement it yet, but there will be that function call. And then I can also add like global variable, for example, int size. It's a global variable where I can use it here, for example, size equals 10, right? And then over here, I want to malloc initially for int multiplied by size, right? And this is the function name. So I need to, if I compile, so let's see what happens if I compile this, right? It will work, right? Because now you have a function called double the size, but it doesn't really do anything, right? But if you have to call that function, it also will not really work because we haven't defined the function name yet. We defined the function name, but we haven't defined the body of the function, right? So we need to now implement the function call. So the beauty of this is, let's say you make some mistakes and then inside you say, I don't know, float, right? Is mismatch between the function signature in the header file and the actual function in your file, it would yell at you now because the header file say that, hey, there should be a function called double the size of take in integer array and integer size. But in your C program, you have the function called the same name, double the size, but take in integer array and float size. this is much easier when you work in a big team and someone design a program, right? Someone design a program and give you the header file and say, hey, this program needs to behave this way. And put in the comment, this function should double the size of your array called ARR with the size right? And double the size of this array. And to reduce the confusion, I'll just do AR size, right? So over here, right, what you're supposed to do, again, as I said, initially what you need to do is create a temp pointer, and then temp equals what? It needs to now malloc a new array, right? That has double the size. So it should be size of int, right? Because each item is integer in size, multiplied by size, multiplied by 2, right? And then you need to also update the size, right? So size equals the size multiplied by 2, right? And you might have noticed this is like a wasted work because you do size multiplied by 2 twice, right? You first can do this, and then this, right? And now at the end, right, you need to free up your array, right? And now in this part, implement the rest for your in-class exercise, right? So step 1, copy everything from ARR into temp, right? Something like this, ARR of I, temp of I equals ARR of I, right? Or the equivalent form of that is the reference temp plus I, right, equal to the reference ARR plus I for all items in ARR. Then the second step, right, is to what? Make sure ARR now point to temp, right? This has to be done after you free ARR, right? After you free ARR. All right, so I will put this code on the, so let me do this. All right, so now everything should be there. Oh, okay. I think you still need to name a variable size. So let's see. I might make some mistakes here because I haven't tried to compile. Oh, yeah. Good point for sure. Good point. Extendable array.h. This should be named AR size, right? And let's not use a global variable because it's generally a bad idea. Because it's some variable that would exist like throughout everything in this particular framework. So people try to avoid that. So let's say int size, right? Initially it's 10. And then in the main function, right? When I finish, right, I want to call this double the size function with the AR array as an input, right? And then the size is the variable called size. So this part in the main function should be correct. It should be correct. The one that's not correct is the double the size function that you have to re-implement and fill in. If you do GCC extensible array.c, you should not declare. All right. Line 8. My bad. Right. But then after you double the size here, you need to make sure you then update the size, right? Because size in there is a new value, but it never get updated. It never get updated. The other thing you can do is now, instead of passing in the pointer, or you can passing in the value, you can pass in the pointer that point to ARR size outside of the main function. That works too, right? So now you can compile. And then let me copy, right? Let me copy everything to the sample code so you can start from there, right? So if you look at /sample code 2022-T1 /lecture 4, you should be able to see that all the sample code are there. And one of the exercise asking you to build this extensible array.c, you can take this code and work with it. All right. Or you can write your own too. That's also okay. So that's the end of the lecture part of today. We'll now move to Discord. So let's do a quick 2 or 3 minutes break. I just need to switch to Discord, and we'll have a Discord session for your in-class exercise. Please do go and try the in-class exercise, right? Light bulbs. The next slides are the same for some reason. And then your in-class is making extensible arrays. So there are 2 things. Making extensible array and perform a prefix sum. Prefix sum is for the practice of using a for loop. And making extensible array basically try to make force you to use pointer and for loop together. We have extension for assignment 2. We're extending from Monday night to Wednesday night. This gives you some more time so you can do a Q&A on Monday. And if you stuck at some questions, this allows you to basically get the Q&A and fix it and make it in time for Wednesday night. Is that okay? So is it okay if I extend the deadline for assignment 2? Anyone against this idea? Please let me know right now on the chat if you're against the idea. You can send me a private chat so that no one sees it's you. All right? If you are against this idea, I'll give you, during the break, you can send me, hey, I am not sure I like the idea of the extension, but otherwise, I'll assume that everyone enjoyed this. I don't know. Seriously, just to be fair, that I asked everyone the opinions, right? Because every decision made is better with the actual opinions if they have one, right? So I would like to make sure I have a venue for you to voice your opinion, and you don't have to tell your friends that it's you. All right, so I will stop the recording so that we can actually put this on YouTube.